Good evening, professors. We would like to present a water project in which we need to use Ethernet software. These are our group members, Ms. Andracho, Mr. Hante, Mr. Kongkante, and me, Kansuite. Let me start with the background first. We choose agriculture area of Chachoengsong province, which is in central Thailand, located along the Bambakol River as our study area. For the details of our study area, the province has 5,351 square kilometer in area, and as of 2018, the population is over 700,000. And for the landscape, there are paddy fields in Western Plain, and the eastern region is hilly. And water demand and supply by here for today demand there. The total demand is 942 million cubic meter, while the current supply is 479 million cubic meter, which only meets 50% of total demand. And the demand for agriculture area is 700 and 800 million cubic meter, which is 84% of total demand. So the additional total demand calculated for agriculture area is 385 million cubic meter, and our study will focus on the demand of 125 million cubic meter. The remaining demand, 264.5 million cubic meter, will be supplied from Kalorabum Reservoir. The challenges are that elevations are there are different elevations throughout the whole province, and limited water supply impact local well-being and development. The reason we choose our study area is that water supply deficit, that only current supply meets only half of the demand. And agriculture impact, the province is mainly for the agriculture. It contributes a lot to the country's agriculture. And for the proposed solution, we will utilize closed CF dam for additional water supply. As for the dam's detail, the dam is 27.5 meters in height and 2,460 meters in length, and it has storage capacity of 420 million cubic meter.
So for the location of the water resources, Klonsia Dam is the main water resources to supply water for the area, and it is situated at latitude 13 degree 26 minutes 39 seconds north, and longitude 101 degree 39 minutes 11 seconds east. So, and it is situated above meeting level 62 meters, and it is also within Chachoengsong province. For the dam specifications, it is 27.5 meters high, 2,460 meters long, and the maximum water capacity that the Klonsia Dam can hold is 420 million cubic meters. For the theory, we use energy equation and Bernoulli's equation. So for energy equations, we use the conservation of energy, in which energy cannot be created or destroyed. It changes forms. And for the assumptions, we assume that the flow in the pipes is steady flow, and it is a compressible flow, and it is also negligible. The viscous forces can be negligible. For the closed conduit flow, the pipes can be connected in series, in parallel, or they can be in branched, or they can be in network. For the pump system, we use pumps. We need to install pumps in the pipe networks for the for the flow of velocity and also the pressure. And for the classification, there are dynamic centrifugal pumps and positive displacement pumps. For the monthly precipitation data, we got the data from HII, and this is the monthly precipitation data of 2022 in the study area for the year 2022. For the calculations, we use the Ethernet software because there are a lot of variables and factors, and we need to set some parameters that are unknown based on our knowledge of hydraulic engineering, so that the analysis is successful. So we need to do some iterations, we need to change the parameters, some of the unknown parameters again and again, iteration, and so that the analysis is successful. And we also set up demands by using a polygon method. And we assume that the supply reservoir, which is the Clonsiet Dam, has the enough capacity to supply to reach all of the demands. And we also install pumps where it is necessary, which is based on energy equation and elevation of the points, and also the pressure within the pipes and the flow of the pipes. For the pump characteristic, we use this kind of pump, and the most important parameter that we had to put in the software are pump input power, which is the 1848.11 kilowatts, and the speed of the pump, which is 990 revolutions per minute.
So for the demand and supply parameter to import an independent solvent, for the supply, we already use it from the Clonsiet Dam. For the demand, we already have to do the agriculture area in junction zones, which is 3,503.5 kilometers square, and the demand is about 385 million cubic meter per year. So these are the following are the serial nodes, which will distribute the water demand. And for when we want to calculate the water demand for node number J64, we already know the total area for the J64 node, which is 111 kilometers square. So we divided that value 111 by the total area of the agriculture area in junction zone, which is 3592.5, and we multiply that result with the total demand, which is 385 million cubic meter. Then we got the demand for J64 node, but the unit is in million cubic meter per year, so we have to convert it into meter cube per hour to import into independent software. So these are the results after we have done for a couple of simulation. So the first one is the head, which is the head of the pipe network system. Here, the head means the elevation head, the pressure head, and the velocity head. So as you can see in the figure, most of the points are above 100 meter. And for the velocity, initially we use the main pipeline diameter above 500 millimeter, and the pipe diameter for the sub pipeline we use about 350 millimeter. But when we simulate the model, there is the negative pressure, so we have to change the pipe size into 1000 millimeter for all of the pipe. So we will have the same diameter. Also, we will have the same cross-sectional area. So the area will be the same in all pipes, but we will see there is nearly zero velocity at the fast junctions because the flow is hindered by 90-degree elbow. For the pressure, there is also the pressure at different nodes, but as you can see in the reservoir, the pressure is 0, which is the blue color, which means that when we calculate the head in the pipeline, we assume that the reservoir, the pressure head at the reservoir is considered as 0. So our simulation is our simulation complying with the theory. So this is the flow. Different inflow through different pipes can also be seen.
So here is our discussion for our final project, and it starts like that. We started our distribution network from Clown Siet Reservoir Dam, which is in the eastern part of Cha Chong Song, and then it is at the elevation of over 100 meter, and we distribute the water from this reservoir to 5 different locations in Cha Chong Song, which is in the northern, western, and the southern parts. There are different elevations. Some points have a higher elevation than our original reservoir, some are lower. So distributing the network with different elevations, we encountered several problems, and the major problems are that the nodes are discontinuous at some points, and also there are also some negative pressures appear after our running the analysis. So we have to be extra careful not to leave any node unconnected while running the Ethernet software. And so if we run like that, the result will create air conditions at these nodes, and we won't get our desired result. And so we eliminated the problem of negative pressure by installing 3 pumps. One just right after the reservoir, and one before the first junction, and the last one after the junction. And so after installing these 3 pumps, our negative pressures disappeared, and the flow is okay, and the run is successful. So yeah, these are the tips that we need to be careful while running the Ethernet software. So the pipes we use in this case are HDPE, high density polyethylene pipes, and they are all 1000 millimeter in diameter. So the pipe is quite big, I must say, because we are distributing the water to all areas of the Cha Chong Song, all these agricultural fields, and there is very high demand. So we had to use this very large pipe to be able to meet the demand. Yeah. So here is our conclusion. Cha Chong Song region that we are considering has a very high water demand to supply ratio. Also, the population of Thailand is also increasing rapidly, and there will definitely be higher demand for the agriculture needs in the future, and which means more water consumption, more water usage, and more higher demand in the water supply. So we designed this water distribution network in this Cha Chong Song region for this main purpose, to meet the future demands. So we mainly distribute the water to the agriculture fields, and we use the GGIS software for the composing and the exporting geographical maps, editing and detailing information, and our Ethernet software, of course, for analyzing and calculating the results. And Google Earth Pro is very essential too. It helps us generating the topographic information about our study area. So with the help of these softwares, the analysis these days and in the future will be very easy and straightforward. Firstly, we need the basic knowledge of hydraulic engineering and how these energy equations and Bernoulli equations works, and how installation of pipes, pumps, and their sizes and elevations impact our result. These basic knowledge are necessary, even though these softwares have in calculating and analyzing to a certain extent. So yeah, this is all for our project and presentation. We hope our project will be a huge help in distributing additional water supply to these necessary areas for the present and for the future too. So yeah, this is all for now. Thank you very much for your attention and time. Thank you.